So in this video we're going to discuss a question that we get a lot over here at DIY Guitar Pedals, which is, will this effect pedal for guitar work on bass? Now the quick answer is, physically, yes. Any pedal that has electricity that is functioning, if you put signal in, you'll get a signal out. So will it work? Yes. However, will it work the way you're hearing it in your head as it should work? That might be a different thing altogether. So I guess that's the first thing we need to tackle real quick here is why people are asking this question. Now I think there are a few reasons why this is asked. What will make this pedal work for a bass? If you typically look at guitar pedals, depending on the design, it may hinder how your bass will sound when playing live or in a mix. Why? Firstly, when applying an effect to a bass signal, the effect may distort or remove the low end of the bass, which kind of defeats the purpose of the bass in the first place. For example, guitar distortions typically focus on distorting higher frequencies to make sure the wet, distorted signal doesn't come out too muddy. When playing a bass, the pedal may cut out too much of the low end before it distorts, resulting in a trebly bass, which in turn means you're not delivering any of the low end to the song anymore. Secondly, the tone and EQ sections for guitar pedals tend to focus on frequencies that make a guitar cut in a mix. Sometimes the frequencies a bass player may want in the mix are not the focus of the knobs on the guitar pedal, and so that may not be optimal. Lastly, there can be little things, like soft and hard clipping sections as an example, where components selected will determine what frequencies to distort that may or may not be desirable for the bassist, but is desirable for the guitarist. And this may be something that needs to be tweaked on if you want to make it work more for bass. So, let's go over 4 things you can do to modify or design your bass effect. So the first thing we're going to look at is adding a blend knob to a circuit. So here we have a bass overdrive schematic. It's a stereotypical overdrive. We have an input signal coming in, going through a little bit of a clipping section, going through a tone stack, and then coming out the other end. However, to note, we have right here an op amp being used as a buffer, where we proceed to go into that clipping section, but we also have a dry signal being split off and then being brought back in with a potentiometer, a blend knob, that teeters the distorted signal and the dry signal into an output buffer op amp and then out the other side. So this works really good for distortions, for boosts, for overdrives, because you're already using some sort of a buffering system probably to deliver that effect. So you can see right here, again, an op amp splitting the signal out, using a pot to balance or mix the 2 signals in, and then an output buffer to shoot it out. That's one way to do it. Let's take a look at another way to do the blend knob. So another example of how to use the blend knob is, instead of teetering between 50% dry, 50% wet, 25% dry, 75% wet, is what if I want 100% of the dry signal no matter what, but I want to dial up or down the wet signal? This is something that you kind of want in modulation effects for bass. So here we have a chorus pedal that's designed to work with a bass. We have our input buffer here, which is a op amp. There's a little bit of gain being done, and there's a little bit of tone shaping. And then it breaks off into the wet signal, going through all the processes to make it a chorus effect. And then we have the dry signal, the clean signal, coming straight through. So when we send this clean signal into the mixing output buffer op amp, it's bringing in, on the bottom side here, the effect, the modulation effect. Well, in the case of a chorus pedal where we want that bass coming in, we want to dial down how much chorus, quote unquote, we want coming into the mix. So we use the blend knob here as a variable resistor to increase the resistance when we want less of the effect and decrease the resistance when we want more of the effect. And that's a second way we can use a blend knob to get our signal in there. So for my final example, before we move on to other ways of making our pedals bass friendly, I want to focus on fuzz pedals. Fuzz pedals we have to handle a little bit differently because we can't use things like buffers at the beginnings and ends of them typically, because it'll mess with the sound. So how can we blend in a clean signal into our fuzz pedal to make it more bass friendly? Well, one way we can do this is this example here. Here we have a Big Muff Pi fuzz circuit. But one of the things you'll notice is, not only does this input go into a wet signal of a Big Muff Pi, it also goes into a transistor boost, an LPB1 type circuit. And using the boost knob, volume knob, level knob, whatever you want to call it, we are injecting our clean signal into our wet signal via these two 10K mixed resistors here. So that's a way we can actually get around the inability of putting like an op-amp buffer at the beginning of our circuit and trying to get it to blend when using an op-amp buffer is not going to be favorable to the sound we want. So that's another way that we can actually add a blend knob to our pedals. But aside from blend knobs, what other ways can we make our pedals more bass friendly? Well, let's take a look. So the second way we can make our pedals more bass friendly is to identify in our pedal circuit where the input and output capacitors are and to potentially change their values. Here we have a DBE Tasmanian Devil PCB project from our site. This is a Proco Rat styled circuit. Here we have an input capacitor of 22 nanofarads, and here we have an output capacitor of 1 microfarad. These capacitors stop DC noise from entering the pedal at its input and from leaving the pedal at its output. However, as they are forming RC filters in this pedal, they also limit the bass frequencies from entering and leaving the pedal as well. One way we can fix this is to increase the value of these capacitors. As for the input capacitor, we could increase that to 47 or even up to 100 nanofarad, and this would be kind of common for a bass modification. As of output capacitors, they can go as far as 10 to even 22 microfarad for high bass output. The rule of thumb is the larger the capacitor, the more bass. However, this has a drawback as well. Sometimes letting in too much bass into your circuit makes the signal muddy, which isn't desired in a lot of instances. So let's take a look at another way we can make a pedal optimal for bass. So another way that we can make our pedals more bass friendly is to identify the tone stack and to potentially change the values within it. So here we have a simple preamp pedal. We have a signal coming in, going into a mu amp, going into a buffer, going into our tone stack, going into another buffer, and then leaving the pedal. So we've identified that this is the tone stack, and this is a common one you'll see on a lot of pedals that have two tone knobs, one for bass and one for treble. This is what is called a James tone stack. Sometimes it's called a passive Baxendale. So what do we got? Well, let's open up our tone stack calculator here, which I'll provide a link in the description below. It's by Duncan amps. It's a very good application for looking at your signal. So I'm going to be on the James tone stack tab here, and I've already punched in the values for what we're looking at. So we can change values in here to what we need them to be just by simply double-clicking on the value and pressing enter. Now, when we start messing with these values, we're looking at trying to target certain frequencies. This is kind of a quote-unquote to taste, but here's my opinion on where a bass guitar pedal should probably have its EQs focused. So at 200 Hertz and below, I tend to cut a lot. The reason being is this is where a lot of the boominess comes in, and if you're in a studio, that's not actually that appealing for your actual mixes. However, there are scenarios like in a live environment where you may want to boost up the 63 and 100 Hertz frequencies when you're trying to compensate for a bad front of house system where they just don't have a lot of bass to push, or in like clubs where the sound system just, again, stinks in the area of the bass department. So in that case, yes, compensating by boosting like 63 to 100 Hertz is good, but otherwise cutting 200 Hertz and below is probably a good idea. Now, as of boosting frequencies, next let's look at like 400 to 800 Hertz, this area right here. For guitarists, that's their mud frequencies, and typically they like to scoop that. You'll hear that term, scooping the mids, a lot with guitar players. Those are the mids they're talking about. Well, if they're scooping those mids, you, as a bass player, should probably be pushing those up and boosting them. This way, you cut through the mix where the guitar is not occupying the sonic space. It's also kind of the mid to higher frequencies of the bass, which has a lot more of the tonal and dynamic qualities of your bass playing. Now we're getting up into the 1000 Hertz. So this is kind of a to taste thing, but 1.3K is a frequency that I'll tend to dip and cut a lot of. Now, if you're a bass player who plays with a pick, you'll know why this is. Because at 1.3K, this is the sound where your pick hitting the string is being heard, the actual clank. Or if you're scraping the pick on the strings, this is where pick scrape is going to be heard really heavy. For a bass, that's not a really good tone, and it makes a lot of racket when you're trying to mix the sound for the bass into your song. So I like to cut 1.3K. However, for high frequencies on the bass, at about 2.5K, this is where your pluck and attack is located at. So for those real intricate dynamics, if you're playing a fretless bass and you're sliding real high up on the frets, or if you're a person who plays a lot of slap bass, especially slap bass, this is where a lot of that pop is coming in and out of. So those are frequencies you may want to boost. Anything beyond like 4K though, that's where you're going to probably start cutting and shelving the top end of your frequencies, because anything after that's just probably noise and not desirable in your sound. So those are the frequencies that you're going to want to target. So all you do in the Tonestack calculator is start just basically punching in values and see what affects what frequencies and what sweeps that you're messing with. And just make sure you're keeping in mind those frequencies that you wish to target for cutting and for boosting. So now we've seen 3 different ways that we can make our pedals more bass friendly. We can add a blend knob, we can change the input and output capacitor values, and we can change the values within a tone stack to target frequencies that are more optimal for bass. So for our 4th method, this is more of a nuanced thing for dirt style pedals like distortions, overdrives, and fuzzes. The idea is for soft clipping diodes. So here we have a DBE Siberian, which you can get off of our site. It's a Big Muff Pie styled pedal. And in that circuit, we have 2 sets of clipping stages, or clipping gain stages, with soft clipping. Now, typically in clipping diodes, you see 2 diodes back to back, one going to the back side of the feedback loop, and then one going directly into the front side. However, in this case, we have a capacitor in series between the 2 back-to-back diodes and the front side of the feedback. This capacitor actually serves as a quote-unquote valve of what is going to get soft clipped and what is not. The larger this capacitor is, the more bass frequencies will be allowed to get clipped, and the smaller the capacitor, the less bass frequencies will get soft clipped. Now, because of this, you can kind of see why with like the Big Muff Green Russian, which has larger capacitors here, why this pedal is kind of a favorite for a lot of bass players trying to get bass fuzz. Because out of the box, it's got that larger capacitor in there, which is giving a nice creamy bass fuzz. Whereas if you were to do like the New York City style, this has a much smaller capacitor, and so it's a lot more nasally and doesn't lend as well to the bass. So this is just one of those like extra little bonus mods that you can do to certain pedals to get it to be a bit more bass friendly. Is if you see clipping diodes, try putting in an inline capacitor to see if you can bring out a little bit more of the distortion with the bass frequencies as opposed to just the treble, if that's a desired effect. Alright, I hope this helps and gives you some ideas as to how to make your pedals more bass friendly, or gives you ideas in what to look for when designing your own bass pedals. If you like these kind of circuit diving videos, please
slap like now,
or leave some comments below. And if you haven't subscribed, please subscribe. Also, if you want to support the channel, please check out our site, www.diyguitarpedals.com.au, and check out our PCB projects. Anyways, that's it for now, and we'll see you in our next video. Cheers.